quite bright. Thank you all for being here, and thanks to Thoughtworks for inviting an external group into a talk, which is a big honor. I really appreciate that. And yeah, the talk's a bit of a mouthful. It's designing an asynchronous microservice runtime with Kafka, and really we're going to be talking about managing state, scale, and performance. And so I've had a few changes since, I suppose, some of the slides. One is I've had a change in my title. So I've Systems Engineering Manager now for the Asia Pacific region. We're growing very rapidly, which is great. And the photo also looks a little bit different. I actually had a full beard, but I decided to try out a mustache for the first time ever. So this is my first public outing. I was actually going to shave it last night, but I decided to go with it. So if I seem a little bit discombobulated, it might be that. So I also worked with one of my colleagues on this talk. His name is Neil Avery. He's in the office of the CTO with Confluent out of London, and he's an ex-ThoughtWorker. I know Scott mentioned early on that there's quite a few ThoughtWorks people at Confluent, and there definitely is, and at fairly high levels. And so Neil gave a great talk, and in this talk he mentioned this article right here, this one, Out of the Tar Pit. And I haven't read the entire thing, I've only read parts of it, but it was from 2006. And one of the key things that it talks about is, first off, complexity in software systems. And back in 1968, there was a paper written about the software crisis, that things were getting too complex and out of control. And this is, of course, in 68, so that's about 46, 48 years ago. So it's amazing that back then they thought things were out of control. And this quote is kind of the crux of the paper, and really the core part of the talk that I'll be giving. And it's, we believe that the major contributor to this complexity in many systems is the handling of state and the burden that this adds when trying to analyze and reason about the system. So you'll hear the word complexity, and you'll hear the word state quite a lot in the talk, and I hope you'll see how we can kind of progress out of that. And thanks to also, as I mentioned earlier, to Duana for her talk. It was a nice lead-in a way. Of course, her talk is very broad and covers a lot of other areas. And this one will be specifically about using an open source system called Apache Kafka to sort of handle some of these patterns. And so I've been talking about Kafka, and of course Confluent is a company that sort of backs Kafka. But quickly, a show of hands, are there people familiar with Apache Kafka? Oh wow, okay, a good 60, 70%, excellent. So this talk is not necessarily going to be going into depth about Apache Kafka, but I do want to give a bit of an underlying view of what Apache Kafka is. And so it's sort of, it means many things to many different people, and I came up with this wording as a way of kind of helping to formalize what I think Apache Kafka is. And it's a bit of a mouthful, and I will read it out for you. I'm sure you may be already reading it, but it's a massively scalable, distributed, fault-tolerant, and again, distributed and fault-tolerant are things that I'll mention quite a lot, because based on that distributed nature and that fault-tolerant nature, we get a lot of benefit from that, which of course flows into the notion of handling state and scale. It's a publish and subscribe key-value data store with infinite data retention, computing unbounded streaming data in real time. So like I said, that's quite a bit of a mouthful, and I'll kind of break it down a little bit. So these are the three key things that I was talking about. Really, it's publish, subscribe, store, and process. So publish, subscribe really came about at the very beginning. So Kafka came out of LinkedIn around 2009, 2010. It was developed in that time. They were suffering this massive deluge of data. They were growing very rapidly, and they had no way of sort of managing the amount of data. So that was all about data flow back in the kind of the early days. But also, they were looking at how can they distribute data across many more consumers without the traditional bottlenecks of message queues, where you sort of have to just multiply your message queues, which is, it's a harder way of scaling. And so June, who is one of the three founders of Confluent, is also one of the creators of Kafka, is ex-IBM and has a database background. And so he built in the notion of a distributed key-value data store into Kafka itself. So that kind of sets the stage for the first 4, 5, 6 years of Apache Kafka, really setting the scene for what I think even today people see Kafka as. And a newer addition to the family, sort of the new kid on the block, is really stream processing. That came about in 2016, and that's where I'll spend quite a bit of time talking about. So just as a quick overview, Apache Kafka is roughly 8 boxes and lots of squiggly lines. But effectively, it's the notion of producing and consuming data and storing that data. So it's a very broad pattern and a very simple pattern, but in that simplicity, we start to tackle a lot of the complexity that we all know and understand from systems. And here's a quick example of a Kafka Streams, how it might work. And again, I'll be going into much greater detail later on, but I just want to show that Kafka Streams application effectively lives outside of Kafka itself. So Apache Kafka is a clustered environment, and then a Kafka Streams application is just your microservice that lives in any way you want that microservice to be. Could be Kubernetes, Docker, on your laptop, whatever it might want to be. And this example is we're taking in an order, we're doing a bunch of stuff with it, and we're sending out a confirmation email. So it also shows that you can actually achieve a lot with Apache Kafka without sort of putting that data somewhere. There's a lot of value in the data in flight. And so what's underneath all of these things? And so another common pattern that you're going to see quite a bit is kind of the rule of threes. And I know that's sort of a pattern that we know in storytelling, and I guess as my background in storytelling, but it's not necessarily, it's actually Kafka has a lot of rule of three, and I do think it comes from that elegance of the underlying design. And so again, we have the 3 boxes, but these are all APIs. So these are the 3 core APIs which really power Apache Kafka. So at the core, we have the producer and consumer API. So really, that's, again, the core pattern with Kafka. If you think of only one thing with Kafka, it's everything either produces data or everything either consumes data. Fundamentally, that's actually the core of everything. On top of that, and every other API and every other system on Apache Kafka is actually built on top of the producer and the consumer API. So it's a very powerful API, but also power brings complexity. So we sort of abstract from that and provide other things. So the Connect API is probably about 4 or 5 years old. And what that did is it allowed Apache Kafka to be used much more by the masses. You no longer had to write your own custom producers and consumers. You could kind of plug in a cartridge in a way, and you just needed to do configuration. And so with that, it really took down a lot of the barriers to entry into Apache Kafka. And to this date, there's probably about 200 to 300 various open source and commercial connectors available for Apache Kafka, which makes it one of the most popular open source systems today. And then lastly, again, as I mentioned earlier, kind of the new kid on the block is really the Streams API. And there's a very low-level processor API, and then there's the DSL, which is a slightly higher level API, which allows you to do lots of the stream processing. And really, most of the things that I'll be talking about today will relate to the DSL, and kind of allowing you to create custom applications in microservices. And again, I'll be speaking a lot on the Streams API as I go along. And so with that, I'm still in the Apache Kafka land, because I'm kind of, again, trying to set a bit of a scene for what is Apache Kafka. Part of that is also what I find in working with Confluent now, and actually my career prior to Apache Kafka was in content management, which is about 1 year and 2 months ago. So I knew of Apache Kafka because of the work that I was doing through making games and things like that, but I didn't know much about it. And so when I kind of came into Apache Kafka, it was kind of with quite new eyes, and there was also a lot of intimidation because you start talking to people from Thoughtworks or other organizations or really large companies, and you realize what they're doing with Apache Kafka. You think, what have I gotten myself into? What I want to do is kind of describe streams in a way that I felt was most relevant. And again, this kind of comes back to the notion of the storytelling that I kind of started with wildlife cinematography. And what I didn't add prior to that is my first job that I wanted to do was becoming an animator. So you'll see there's a proper use of animation in the rest of this talk. So again, with the rule of three, we have things like topics, which I will kind of break down, but again, are core to Apache Kafka. We have the stream itself, and then we have the underlying table. So these 3 things are what builds up the Streams API and what really powers the rest of kind of the event streaming platform, which Apache Kafka is, and also underlies the talk itself. So with topics, we have the notion of effectively everyday events. And so again, as I said, I'm a huge fan of animation, especially Studio Ghibli. So in our first box, we have transportation. In our second box, we have recreation. In our third box, we have dining. Again, these are all events that are happening every day. These are things that are immutable. They're facts that are occurring all about us, and really everything ends up being an event. And so those events, if we kind of slow that down and pause on essentially on just one frame, we can kind of zoom into that and kind of break it apart a little bit. And so we can imagine that if we were going to model, say we were going to model an animation studio using Apache Kafka, what we would do is we would potentially break those layers apart. We would have the bottom background layer. We'd have the foreground layer that just went up to the top there. And then we have sort of our characters. And I should have had those characters also sort of move apart a little bit. But anyways, Keynote does have its limitations. Keynote's very good, though. There's no laser blasts or explosions, though, unfortunately, which would be kind of cool, actually. So now what I've done is I've kind of sandwiched those things back together. And again, we're thinking about how does data flow into topics within Kafka. So let's again imagine we have these three topics: background, foreground, and then the actor sort of topic. And so we have two actors here. We have the bear and the raccoon, and we're just sort of storing their x and y coordinates. And so as they walk through the forest, as bears and raccoons often do, wearing a top hat and a nice purple jacket or whatever, where you can actually, the x and y values are subtly changing. So again, these are all frames of animation, but sort of if we took snapshots of time, we would be able to sort of zero these things out. I shouldn't say zero them out, but we'd be able to capture these things and put them into that stream of our topics. So again, they change one more time. So now we've stored roughly 3 or 4 different pieces of data into our partition, and we have those 3 partitions. So that's sort of a nice way of looking at how taking sort of real-life events, whatever they might be, and again, this is just this pretend sort of animation studio. The other aspect of what makes the Streams API is the stream. So of course, that kind of makes sense, but it's kind of odd that the stream is actually in the Streams API. But really, what the Streams API, what the stream is doing is it's taking all of those individual sort of frames of animation or all those single events. And you can sort of see as, I'm playing out, here's May from Totoro chasing or trying to capture one of those little dust creatures that she found when they moved into the new house. And she thinks she has it, but this misses it and actually is not in her hand if you've seen Totoro or not. It's a good movie. And so what's happening in that streams layer is it's taking all of these individual immutable events that are at rest in the log, in the immutable log, and it adds the ability to compute and reason and aggregate and window and replay and things like that. So it's really animating those partitions and allowing you to interact with them with that kind of that third dimension of time backing it up. And of course, there's the Streams API now animating that. And then the third key component of the Streams API is the table itself. And so it sort of seems a bit odd to be talking about data and streams and time, and now we're kind of back to a table. And in some ways, how does Kafka handle tables? And kind of staying with the animation workflow here, animation has things called exposure sheets. So that's a really great way of breaking down animation. So you'll see every single frame of animation relates to some sort of cell back. And again, this used to be way back when we used to actually write on paper. And here you can see this is about the grasshopper sings a song. And the song he's singing is all I do is have fun. And interesting enough, you'll see that, because I love animation, sorry, I'll kind of digress a little bit, but you'll see that all is AOL. Because when you're doing the mouth sounds, it's more realistic to use the O to open up the mouth a bit further. And then do is DOO, because you kind of have to accentuate the voice or the mouth a little bit. So you'll see that even though it's all I do is have fun, the dialogue is actually spelled a little bit differently just to help accentuate the character's mouth, which I quite liked as well. So this goes really well into the notion of kind of rewinding a little bit into a change log. And so we're all I'm sure if I ask people if they're familiar with the database, we'd probably see everyone raise their hand. And so I think we're all used to what a table looks like. And this table is a very simple table for a reason. And we have Alice and 1. And then as we go down, we have Alice 1, Charlie 1. And you sort of see that table is changing over time. But in reality, the table is lossy, because if I was to look at that table right now, you're only going to see Alice, Charlie, Bob, 2, 1, 1. You're not necessarily going to know that the table used to only have 2 values, that Alice's score used to be 1, and that actually when this table first started, or when this project first started, there was just 1 player in that game, which was Alice. And of course, all these things are happening into a change log. So anytime you're interacting with a database, you're actually interacting with the log. You're not interacting with the table. It's sort of that nice kind of matrix sort of thing, but you're interacting with the log, and then the log is what's actually the source of truth, but we just think of a database actually as a table. And so, of course, with Kafka, we are actually interacting with the stream. So here you'll see Alice 1, Charlie 1. You see these are all the different events that have flow in over time. And with Kafka, you're capturing those events. And you can then see how you can then rebuild that table back again. So let's just say we have a table. In the middle, we have a change data capture that's capturing all those events. Duana mentioned that in her talk. And then, of course, we can then re-represent that back as a table by replaying that change log and then having a table being essentially recreated over time. And so within Kafka, this is sort of known as the stream table duality, which is kind of a nice coffee term you can use at dinner or something like that, or at if you're having coffee with a friend. Makes you sound really interesting to other geeks, maybe. And with that, that's the close of the animation section of the talk. So we've talked about events quite a bit, and really all of your data is a stream of events. And so, where does the database fit into that? And talking about scaling data and things like that being hard. So again, this kind of comes into the notion of what is a database? And I think the usefulness of a database is very obvious to us. We've been using databases, as even I was talking earlier. We've kind of, sometimes we forget about the fact that it's actually a log, unless we've had a database crash or we're backing it up. But we tend to kind of forget that. We've abstracted further up the food chain in a lot of ways. And so, again, the usefulness of a database is very understood in sort of a command request or command query type of pattern. Whereas the notion of a stream or events is newer. It's something that I think we've only had a smaller amount of time to get used to. So I think that's going to change over time. I see that it's still newer. And Duana mentioned quite a few really nice patterns, and I know there's lots of different things like that. But I think over time, we'll start to get used to the fact that the database is still incredibly useful. But rather than thinking of data having to land in a database before it's useful, we can start to look at events as being useful on their own. And a database becomes effectively a materialized view into that data at any given time. And so I think the key thing to think about there is the fact that you don't necessarily need the database to be your canonical data store. And in fact, that coupling to using a database as your canonical data store, many times creates a lot of, I'd say, potentially anti-patterns. I know that's a little bit much because we're still all doing these sorts of things. But again, this sort of thinking helps to kind of lead into where I'm going to go with the rest of the talk. And this one is again, quite a bit of an aside. But again, I think it's quite nice to think about Kafka in a very philosophical way. And I was back in the United States last year for an entirely different reason. And I was having dinner or lunch, actually, with my brothers, which is really nice, which is a nice treat. Again, I didn't mention this early on, but I think Scott and a few others are expats from the US. I'm originally from North Dakota, which is an incredibly landlocked state. It's the least visited state in the United States, and I think I'm probably the 5th person to get a passport. So if you want to visit, it's a beautiful place, and the documentary I did was on bison in North Dakota, so it's quite dramatic, and it's still playing on Prairie Public Broadcasting, I think, every once in a while. So, but anyways, back to this. The usefulness of a cup is in its emptiness, and that really caught me at the time. It meant something very different at the time, but it really caught me, I think, as I think about Kafka, because I think we oftentimes all assume, especially there was quite a few hands raised about what Apache Kafka means to people, is everyone would probably have a different view of what Apache Kafka means, or what it means, what it's used for. So it might be used for publish and subscribe, or it might be used for an MQ replacement, for instance, or it might be used to push data around your microservices, or maybe as an endpoint to get data into Hadoop or HDFS. But the thing is, it's actually all of those things and none of those things. So the usefulness of Kafka is in the simplicity of Kafka. And I think, again, this is sort of setting a scene for where we're going to be going here. But it also reminds me, too, of a story. Again, I talk about stories all the time. My wife and I were talking to our daughter just a few months ago, and she's 15. She's in year 10. Year 11 starts next year. And again, this is something that I'm new to. In Australia, year 11 and 12 is really tricky and hard and complex, and I don't understand any of it. Whereas in America, you just went to 10, 11, 12, graduated, and then you just do whatever you want for university. But it's so important to nail it, in year 10, 11, and 12, and you have to know what you want to do. And so anyways, we wanted to be these amazing parents and bring our knowledge and wisdom into our daughter. And so we sat her down, one on each side, of course, in a nice confrontational standpoint. She's in the middle. And we said, you need to make sure you get things right and do all this, and you need to really stick to it and work really hard. And it didn't quite go very well. As parents, we think, oh, we have all this knowledge, we just need to beat it into our children, literally, sometimes. And I've got 4 kids, by the way, so it's I don't do a good job all the time of that sort of thing. But what we're trying to get across was this, and there was a nice long pause, and as she was sort of thinking through things, and maybe a bit of tears, and she sort of thoughtfully said to us, she said, you keep saying you want me to be like an adult, and you want me to be thinking about all these things, and yet you treat me like a child. So you think, how can you expect me to be an adult if you treat me like a child? And I thought, wow, that's very, very deep, and it's so much more insightful than I could think of ever come across. And so I know it's quite a bit of an aside, but coming back from that family story, but it's really about, I think, approaching things with quite a broad view and not making these assumptions and expecting these sorts of things out of it. So again, excuse me for the for the bit of things over there, but again, it's really about almost in a way a philosophical view of how you can look at Kafka and how you can look at your systems in a really kind of almost flipped way, or on the side a little bit. So we kind of come down to the fact that streams are your persistence model, and effectively they become your local database. And so again, you think, well, really, like how in the world would you actually treat Kafka as a database? So you kind of don't, but I'm just saying that again to help kind of frame that. But definitely thinking of Kafka as your persistence model, really Kafka becomes your source of truth, which kind of leads into the Kappa architecture, which I'll be covering really quickly. So all those things kind of lead into the Kappa architecture. And the Kappa architecture is really about everything is a stream. And so here's a quote from Heraclitus. Basically, and I know this isn't quite worded right. I read there's quite a few different, of course we don't probably know what he really said back a few thousand years ago. But effectively, it's sort of, you can't step into the same stream twice as the waters are forever flowing. He's also said things like, the only constant is change. So I really like that kind of philosophy, because again, it really flows well into Apache Kafka. And so it's that notion that things are always changing, and we need to account for that. And you can't expect to go back and experience the same thing, because effectively, that has moved on from that point. And that kind of turns into this notion of turning the database inside out. This is a really brilliant blog post. It's quite old now. It's from, well, 2015. It seems not that old, but in technology that's ancient. Written by Martin Kleppmann. Martin Kleppmann also worked at LinkedIn around the same time that Jay, Neha, and June were there. And he was quite instrumental on some of the ideas around Apache Kafka. And it's a really brilliant blog post. I recommend, if anybody's interested in some of these concepts, to read that at some point. To me, it was one of the first things that I read when I first started working with Confluent, and it really fundamentally gave me the aha moment as to why this is such an exciting technology. And so I think you kind of understand what I mean by turning the database inside out, because of the fact that we talked about that stream, that change log, and we had the 2 tables on each side. We're basically turning the database inside out by turning that change log, or that change stream, actually as the first-class citizen, and then the materialized views become just that. They're just a view into your data, but your data is not the table or not the view. And so you see, I just had a little bit of an animation here. This is from a bit earlier on where I talked about everything as a producer or a consumer. Everything is flowing within Apache Kafka. So there's always data coming in, and there's always data going out. And there's sort of three key kind of items that are around what makes the Kafka architecture. And one is the log data store. The other is streaming computation. And then lastly, it's the serving layer, which I've kind of been calling the materialized view a little bit. And I think the log data store is something I've covered quite a bit. That's about the fact that we have a place that we can store all these immutable facts over time. The ability to do streaming computation, which again, as I showed in that streaming section. And then lastly, the materialized view. And I think the thing that I want to point out here is there's two key points there. First, you choose the view or the engine that is the best query that you want. And the second is that it is not your canonical data store. Do not treat it as you have to land your data into Elastic or Redis or something before you do something with it. And here's sort of an expanded view of what that looks like. So sort of, I've sort of overlaid, again, with some drawing here, the different things. So we have that notion of that log data store, which is, of course, Apache Kafka. We have the streaming computation system, which is Kafka Streams, which I will be coming into shortly. And then lastly, we have that serving layer, which is really that all-important serving layer. So here you'll see, for instance, there's BigQuery, there's Elastic, the microservice itself is a serving layer, and you could have one of hundreds of different connectors that are, again, readily available. Or if they're not available, you can write your own using the consumer API. And again, as I referred to them earlier, as materialized views. So again, this is sort of a similar pattern, but I've again flipped it over. You sort of see I kind of do that every once in a while to maybe some people can appreciate something in a slightly different way. But this effectively is showing what a materialized view is. So we have data flowing in from the left side here. We have, of course, Kafka and then potentially Kafka Streams and K-SQL, which is potentially doing processing on that data. And then we have that data flowing out. And again, it's not the notion of that data is flowing out and then never coming back. I think the key thing there is the data is flowing out into those materialized views, but it's also still being stored in Kafka as your canonical data store or as your source of truth. And again, there's a really great, another great blog post that I read by Chris Riccomi, I think is his name. It's Kafka is your escape hatch. Again, he's a LinkedIn engineer, so there's a lot of LinkedIn people that write about Kafka because it originated there. He wrote this great blog post which really says that with Kafka, it actually allows him to experiment and fail fast because he doesn't have to put all his eggs in one basket and try a new technology. And so he said that it really prevents vendor lock-in and a lot of things that he doesn't have to worry about anymore, because if a system that he tries or buys doesn't quite work, it wasn't the canonical data store. He can just sort of rip and replace it and then put in something else, and that data will flow into that, or they can replay data back into that new canonical data store, or sorry, that new data store, because we have a canonical data store. And so kind of leading into another part of the talk here is the notion of two different kinds of processors. So we have the event processor and then the stream processor. So again, I sort of like to say old world, new world, you got to be a little bit out there. But the event processor is something that we've been fairly accustomed to, not as long as databases, for instance, but nearly as long as databases. And the event processor is sort of the notion of handling an event at a time. So we have an event coming through, whether a microservice or whatever, and we handle that one event, and then we do something else. I have some diagrams of some quick examples of that shortly after this. And then sort of the kind of the newer idea of that is really around stream processing. It's the notion of you're dealing with a set of events. And so you're not dealing with just one event, you're dealing with a set of events, as I was, again, talking about earlier about streams and things like that. And those set of events really give you powerful primitives, things like context. All of a sudden, you can bring in context from databases, from external systems, and from multiple events themselves. And once you have that, you can start to join data together, again, in real time as the data is flowing through. You also have the ability to aggregate and to compute and join different things. And you also have the ability to window as well to allow for things like late arriving data. And again, Duana talked a bit about that in her talk. And so here's a really classic architecture, sort of an RPC type one, where we have 3 microservices. So we're doing that well. but we're kind of introducing that tight coupling where we do have events flowing, but we're sort of that command request type thing, where not the publish and subscribe type of mentality. And so here, as Duan was talking about, you're telling something to do something, and you're making shipping service talk directly to other services. So we're creating a lot of tight coupling. We're making scaling hard, and all the negatives that Duana did a much better job talking about. And no Kafka, so sad emoji. So again, I'll kind of go through this fairly quickly because I have other things to talk about. But here I'm just going to actually skip through this one because I want to touch on this one. So here you can sort of see what we've done now is we've, very quickly, so good job, development team, we've introduced 3 different topics. And you'll see one of those, the bottom one, is via change data capture. So again, I'll touch on that briefly. But what we're starting to do is we're starting to use that notion of the microservices themselves are distinct, and we are really decoupling them and forcing them to push their data, whether that data is events or actual data from a change data capture or something, into Apache Kafka itself. And here's that same diagram that I showed you earlier, but this one is showing that notion of customer, and customer here is through a customer database, and then that's change data capture. So again, kind of quickly to showing the benefit of a K-Streams application, allowing you to take an order, you're looking at the customer's email address, and then you're sending an email to that customer. And then also part of this is the notion of using things like K-Sequel. So K-Sequel is sort of a higher level stream processor language on top of Apache Kafka, Kafka Streams. And so here we can sort of just use text and actually create a whole, whereas here, if I go backwards, it's going to work. Oh, never mind. If we go backwards, you'll sort of see that you need to write, with Kafka Streams, it's a microservice, so you need to write that in a JVM language. K-Sequel, of course, is something that you can use for just text. And I want to touch on event streaming pillars, and so this will be the rest of the last part of the talk. And in event streaming pillars, there's 4 key areas. So there's business functions, which are all about managing state. There's the instrumentation plane, which is about trust. How do I trust this asynchronous system? And I know, again, Duana touched on that. We have a control plane, which is about coordinating. And then we have an operational plane, which is about running. So in the notion of business modeling, we also have the notion of different types of events. And again, I know Duana touched on this a bit briefly, in her talk as well. But we have domain events, for instance, and these are kind of the traditional view of what an event is. So these are sort of microservices talking to each other, or kind of domain things that are happening between the business. We have domain data, which, as I was showing briefly, is things potentially like change data capture or streaming in data from other systems into Kafka to make it available, and even things like time series, things like IoT and sensors. So when we're thinking about events and streams, there's kind of different qualities or different contexts of streams that we should also keep in mind. It's not all just the same type of message and things like that. And the example that I'm going to show here briefly is Rotten Tomatoes, or Rotten Tomatoes for my American counterparts. So again, this is all about sort of a quick rating service. And so in this rating service here, and again, this is very, very high level, not meant to be at all prescriptive at all, but we have a browser, we have a web server, and that web server is sending sort of ratings to this service, the rating service here. So at the purplish color, we have raw ratings. And then the rating service is doing Kafka Streams and things like that, and it's producing curated ratings, rating counts, and rating sums, again, using Kafka Streams. But as we're evolving this rating service, we also want to start introducing maybe recommendations for other movies for these groups. And so we need to get movie data into our microservice. So a traditional way of doing that would be to stand up another movie service and then start to talk directly to that movie service. But in here, what we've done is we've introduced a change data capture. You sort of see at the bottom there, where we're flowing data from the canonical data store, which is on the web server, via change data capture. And we're then pushing our movies data into a topic. So that's a changelog topic. And then what we can do then is we can use a K-table within the rating service and materialize that as a K-table. So what that means is we have a canonical data store, which is on the web server, but we're able to take that state and put it into our microservice as a K-table that we can interactively query anytime we want. So now when we are moving on, we want to have a rated movies topic. all that can be very self-contained within that one microservice itself. And you can imagine that's sort of that bounded context of the rating service, and we can have additional bounded contexts in other areas. And as we evolve this even further in that rating service, we start to actually introduce its own database, and we start to need to actually capture events for themselves from that microservice as change data capture back into Kafka. So you can sort of see that cyclical nature as you evolve things over time. And again, bounded contexts were mentioned earlier, but it's really the notion of, and it was a great notion of how choreography and orchestration. So I'm glad I hope I got the right term, Duana, if she's in here. Choreography instead of orchestration, so that you can actually take multiple bounded contexts and have them talk to each other, and yet not start to couple them together. And within that bounded context, if this is payments and logistics, they can have their own namespaces and their own words for things or whatever, and they can even pull data from those canonical data stores, and yet not sort of muddy the waters with the other ones. And how do we start to scale these things out? So it's all about partitioning. And again, I keep on referring to Duana's talk. It was great. Thank you. She talked about partitioning. How do you partition books? And so here we are partitioning on a user, for instance. It's already on a book, on a BID. And you'll see that key allows the hashing of that algorithm. So we have a consistency that our different keys go to the right partition. And then here you'll see this consumer group is able to, you can scale that consumer group out to, there's something in Kafka called parallelization, which allows you to have as many consumers as you have partitions. Now, we extrapolate that out into a microservice. We have, again, 3 partitions, 1, 2, and 3. And that allows us to launch up to 3 stream processors, and they all each are able to grab their key, and the same key will go to the exact same stream processor, and that's guaranteed. Again, that was nicely covered in Duana's talk. And of course, we have interactive queries, and then from that microservice, we're actually using those K-tables, and those K-tables emit events because it's an event. And so you can actually attach change data capture to those K-tables to capture even new derived information into something like an elastic data store. So kind of moving on to the next pillar, which is about trust. So really, when we're dealing with asynchronous systems, kind of common thing is I don't like it. It's scary, it's dangerous, it's new. What about failures, upgrades? It's hard to know what's happening because it seems like you're just throwing something out there and you don't know what's going to go on. And so making sure that you have trust is a really core part of architecting a system around events and stream processors. And so those are things like understanding your business metrics and encoding them in your processors directly. So this goes to a payments sort of microservice, and you want to know how many payments are in flight, if they're complete, what's your SLAs, what's your timing from being produced to consumed, and you flow those things all into some sort of a dashboard here. So this is sort of similar to like open tracing, which is also kind of gaining popularity, again, as I think as event streaming systems kind of come in more and more in microservices. So it's the notion of knowing that you're hitting your metrics and building those into your microservices. So your microservices are consuming events and they're emitting events into that instrumentation layer. The next one is the control plane. So the control plane is about what happens in a disaster. So not only a disaster, but also what happens when you need to take the system offline to scale it up, or what happens if you need to basically do anything, and really accounting for that early on. So it's almost the notion of play, pause, and start. How do you finish things that are in flight? How do you allow things to end gracefully? How do you allow for things to then start back up again and pick back up? And so within Kafka, again, because everything that's happening in a stream processor is being materialized back to a Kafka topic, which is then being materialized across multiple brokers, which is distributed in a fault-tolerant way. If that microservice crashes or goes down, you're able to recreate that state very quickly. So I realize I've mentioned too many family stories. I'm running out of time. Sorry about that. Next time I'll lessen the stories. Fortunately, I'm nearing the end. And the last pillar of this, and actually rather than pillars, it should have almost been called the event streaming Tetris or something like that, because they're actually quite intertwined. And the operational plane is really about all of the things that, funnily enough, Kafka became famous for. application logs, error logs, audit logs, lineage, and things like that. So Kafka kind of came from that world of storing this information, and oddly enough, now it's emitting that information for other systems to aggregate. So again, it's thinking about, as you're developing these stream processors and these microservices, you need to also be emitting all these events so that you can store and record them and monitor them through multiple different systems. And so I'll just quickly go to the last slide here. So I'll leave you sort of with this notion of a mental model here. So we start with an event, which we covered, and which has been covered quite well. We move into the notion of a stream. So a stream is basically taking one or more events over time as they occur. And then we've talked about a stream processor. So a stream processor allows you to do interesting things with those streams of events that are happening. We also touched on bounded context and orchestration. So that's the, should have been choreography. I did get that one wrong. So that, I'll fix that. But bounded context allows us to create multiple different microservices and have very loose coupling between them. Because again, we're using the same primitives as we go on. And then lastly, it's built on those pillars of business functions, instrumentation, control plane, and operations. And all of those things flow back into Kafka. So Kafka serves as that event streaming platform really at the heart of your group or your project, and you can then push data into it and also be reading data from it in various different ways. And so, yes, the usefulness of a cup is in its emptiness, and thank you very much.